4 minutes. That is literally all it takes. That's the average time between a secret being accidentally pushed to a public GitHub repository and an automated scanner finding it and trying to exploit it. I want you to look at this real 4-minute GitGuardian breach alert. Scanners are out there running continuously, globally, and indexing every single public commit in real time. And, it's not just accidental public pushes we have to worry about. Secrets leak in CI/CD logs, in Docker image layers, and in environment variables. This is exactly why we're sitting down today. As your senior lead, I want to completely revamp how we handle our secrets before you make your first big production push. Welcome to this explainer. I'm going to mentor you on exactly how we replace those dangerous, long-lived credentials with actionable, modern, and highly secure workflows. My goal is that by the end of this session, you're going to understand exactly how to build pipelines with zero stored credentials. Okay, let's dive into the agenda. We'll be running through the breach reality check, how to eliminate stored AWS keys, encrypting safe Git commits, setting up Vault for dynamic production access, fixing some really common setup errors, and I'll leave you with a pre-push checklist. Section 1. The breach reality check. Before we choose our solutions, we need to understand exactly where these leaks happen. Take a look at the massive blast radius of static secrets compared to the dynamic workflows we are going to build. A static, long-lived AWS key, or a permanent database password. That's just a ticking time bomb. Think about it. If it leaks, an attacker has literally unlimited time to exploit it until someone realizes what happened and manually rotates it. The dynamic flows on the right completely eliminate this risk by making secrets ephemeral. They have a strict time to live, or TTL, and they just expire on their own. And here is a classic example of what absolutely not to do. Never ever bake a secret into a Docker file layer. If you write your database password directly in a Docker file, like you see on the left, that secret is permanently baked into every single layer of every image pulled from that tag. It lives in the layer cache forever. You always want to inject secrets safely at runtime, passing them in as environment variables or pulling them through Kubernetes secrets. All right, section 2. No more stored AWS keys. Let's get into OIDC. OIDC, which stands for OpenID Connect. This is a total game changer. It's an upgrade that means no AWS access key ever needs to be stored in GitHub secrets or environment variables again. Instead of a stored permanent credential, GitHub Actions actually mathematically proves its identity to AWS. AWS verifies it and then hands back a short-lived temporary token that's valid for exactly 1 hour before it automatically self-destructs. Nothing is stored, so there's absolutely nothing to leak. So here are the exact actionable steps you need to take to establish that trust. First, you configure GitHub Actions as an identity provider directly in your AWS IAM console. Second, you create a web identity role. And finally, inside your GitHub Actions YAML file, you've got to add the permission idtoken.write. That is the exact line of code that allows your pipeline to request that short-lived OIDC token. Now, this trust policy condition, this is your gatekeeper. It ensures the specific role can only be assumed by workflows running from our main branch. The subcondition you see right there is the specific claim that has to match. A workflow on a random feature branch, it cannot assume it. A completely different repository? Nope. It is incredibly granular, zero trust access control. Moving on to Section 3, encrypting safe Git commits. Let's talk about third-party API keys. OIDC is amazing for cloud credentials, but for things like Stripe keys, we need a safe way to commit them to Git. Enter SOPs, a fantastic tool created by Mozilla. What's really brilliant here is that the keys themselves remain totally readable, so you know what's in the file, but the values are completely transformed into ciphertext. This means your labels are plainly visible, so the team knows the configuration exists, but the actual sensitive values are AES-256 encrypted. It's a completely lossless transformation, and that file is now perfectly safe to commit directly to version control. Let's walk through our exact SOPS configuration workflow. It's super straightforward. First, you generate an age key pair on your local machine. Second, you encrypt your .env file using SOPS and your public key, and then you just commit it safely to your repo. Finally, the only thing you actually store in GitHub secrets is that single age private key. At runtime, the pipeline just uses that private key to decrypt the file. And the best part? If you ever need to rotate your secrets, you only have to rotate that one age key. The whole shebang is so much easier to manage. Section 4, Vault, Dynamic Production Access. Time to upgrade from static passwords. HashiCorp Vault takes this to a whole new level by creating dynamic secrets.
Imagine your pipeline needs to run a database migration. Vault actually generates a brand new database password on demand that exists for exactly 1 hour, and then poof, it vanishes, leaving nothing behind to leak. The database literally has no permanent application user. Since nothing persists, nothing ever needs to be rotated. It's pretty amazing.
The crucial piece here is this dynamic workflow. Your pipeline requests access by authenticating to Vault, using that exact same GitHub OIDC token we talked about earlier. Vault verifies the pipeline's identity, and a unique one-time credential is born just for this specific deployment. The deployment finishes, and Vault automatically kills the credential when the hour is up. Plus, Vault logs every single issuance and expiration, which gives us a flawless audit trail. Okay, Section 5, Fixing Common Setup Errors. Let's look at some anti-patterns before you fly solo. Here's a mistake I actually made early in my own career. Never, ever print secrets to your CI logs. Even if you think GitHub masks them automatically, it builds terrible habits. The fix is twofold. First, obviously, never use an echo command for a secret. Second, we configure a tool called GitLeaks to run as a required status check on every single pull request. It scans the diff for over 150 different secret patterns, and it physically blocks the merge if it detects anything. We want to catch the breach at the commit stage, not after the push. This next one is a massive, massive breach risk, using the exact same credential for all your environments. If you use the same Stripe API key for dev, staging, and production, it means a leaked developer key instantly gives an attacker access to your live production data. Absolutely not. Always use one least privileged credential scoped per specific environment. In GitHub Actions, you do this using environment secrets, so a workflow only unlocks production secrets if it's explicitly intentionally deploying to production. Finally, Section 6, the Junior Pre-Push Checklist. Let's wrap up with some firm guardrails. Before you push any sensitive code, I want you to run through this checklist to enforce these new rules we've set up. Verify that you aren't hard-coding any long-lived AWS keys. Use OIDC instead. Make sure the GitLeaks action is actually running on your PR. Confirm your static .env files are fully SOPs encrypted. Check that your GitHub environment secrets are properly scoped, so dev absolutely cannot touch prod. And finally, ensure your Vault dynamic roles are tightly restricted to that 1 hour time to live. You know, secrets management isn't just about picking one cool tool. It is an entire layered defense system of preventing, detecting, containing, and recovering. We prevent leaks before the commit using SOPs. We detect them after the commit but before the merge using GitLeaks. If a secret somehow does manage to slip out, we contain the blast radius immediately because those OIDC and Vault credentials will expire in an hour anyway, and we recover instantly by rotating our single SOPs key and checking our CloudTrail audits. So I'll leave you with this question. If your pipeline leaked a credential right now, how many minutes would it take for it to expire automatically? Really think about that. Apply the layers we've discussed today and make sure your answer is always before the attacker even finds it. Implement OIDC, use SOPs, leverage those dynamic Vault secrets, and you will effectively make credential breaches a thing of the past for our team. Thanks for joining me in this explainer. Now let's get out there and secure those pipelines.